solve these compound inequalities. They're called compound because there's more than one. So the first one is 3x minus 4 less than negative 7. If we add 4 to both sides, we end up getting 3x less than negative 3, and then dividing by 3 yields x is less than negative 1. So if I was going to try to sketch that on a line really quickly, I would have a negative 1 value located right here, and then I would have a parenthesis opening to the right because I want the numbers that are, oops, I put it the wrong way. We would have a parenthesis opening to the left because we want the numbers that are less than negative 1. On the other hand, if I came over here, 2x plus 2 bigger than or equal to 12, subtracting 2 from both sides would give me 2x bigger than or equal to 10, and then dividing by 2 yields x is bigger than or equal to 5. X is bigger than or equal to 5. So on a number line, that would look like coming to the number 5, and then we would have a bracket, and since it's bigger than, we would be pointing to the right, shading to the right. Now with the key phrase of or, that means that either one or the other could work. So when we bring them together into our final answer, this red graph will be our final graph. We need to take all of the things that were shaded in either one picture or the other picture. So we need numbers that are less than negative 1 to the left of negative 1, and also numbers that are to the right of the number 5. So this one's a long shade, I call it the wings in class, right? Because we have things to the left and things to the right. So this is the graph of this particular inequality. Here's a second example with an and this time I'll use the other notation rather than bracket and parenthesis, which is good for intervals. We'll use the open dot, close dot. So the first inequality, add 4 to both sides. 2x is less than or equal to 2. Divide by 2, and x is less than or equal to 1. So number line, 1, and closed dot because it's less than or equal to, and shading to the left. On the other hand, for the other inequality, add 3 to both sides. 2x is bigger than negative 12, and then divide by 2, and x is bigger than negative 6. So in the second inequality, we're going to come down here, go to the number negative 6, bigger than not equal to, so that's open dot, and bigger than, so shade to the right. Okay, with this connector word is and, we're now going to need the parts that are shaded in both the top picture and the bottom picture. So on our number line, we'll have the number negative 6, we'll have the number 1. 1 is included in both of the pictures because it was solid in the top one and shaded in the second. And negative 6 is not included in both the pictures because although it's shaded in the top one, in the blue one, it's an open dot in the green one. So the final answer for the shading is going to be in between those two because that's the part that's shaded by both of the pictures. And in class I call this overlap, so we have the overlapping piece. Okay, final question for you to try on your own. Pause the video and see if you can do this one. And assuming you gave it a shot here, gave it a second and see if you can do it, I was pretty sneaky this time. This is compound even though you only really see one sort of expression here, one phrase, one inequality, because it has two inequality symbols in it. So to solve this one, we're still going to use the same philosophy and try to isolate the x. So we're going to get rid of it by adding 1 to both sides, all sides of the inequality. Negative 2 less than 2x less than or equal to the number 10. Now divide by 2 on all sides of the inequality to give me negative 1 less than x less than or equal to 10 divided by 2, which is 5. So this time I'm going to be able to easily jump down to the final graph instead of having to go through the two intermediate steps and say that on the low end I got to go down to negative 1. I'll use open dot this time, could be open dot or parenthesis. On the upper end, the higher end, we have a closed dot at 5 or a bracket at 5. And now you can physically see that the x is in between those two numbers, and therefore the region you're going to shade is simply the region in between those two endpoints.